All right, we're going to do work and distance. This is the section 1.4. These are word problems, so pay close attention because these are more difficult than others. And let's get started. All right, this is doing work. Okay, so today we're going to be doing problems that include work. Now, we're not talking about, in physics, there's a type of work where you push something in and you see how much work is exerted. This is the kind of work as if you're going to paint a house and how much time it might take. Or you're going to rake some leaves or picking up around the house and etc. All right? And these will at least involve more than one person. All right? So the work usually involves two people working together to do a job. And that's the kind of work that we're going to talk about. When we do that, we're going to make an equation from the information. And I'm going to give you, here's the tip right here to help you make your equation. You might want to write this down. You're going to make a fraction. You're going to make a what?
Fraction.
A fraction of the work done in either 1 hour or 1 minute or some unit of time. Okay? So it could be, most of the time it will be hour, minute, second, some unit of time. The key is here, we're going to make a fraction. It's really important that you remember that you're going to make a fraction. The cool thing is that your calculators will add fractions for you, not a problem. All right, we're going to practice. This is not one of the word problems, but this is going to help us make the fractions, okay? So we're going to practice on this one. If it takes 3 hours to do laundry, what fraction, how much do you get done in 1 hour?
Yeah, 1/3.
1/3 of it, right? Okay, so if it takes 3 hours to do laundry, in 1 hour you can have 1/3 of it done, right? Okay, so that is the extent of the fraction that you're going to have to make.
Do my
all right?
laundry if it took 3 hours, dang it.
If it takes 45 minutes to mow the yard, how much can you get done in 1 minute? 1/45.
I wish my laundry
That is exactly right. So you have 1/45. That is the extent of the fractions that you're going to have to make. Now, let's put them into equations on how to do that. So let's do some of these together. We're going to do numbers 1, 2, 7, and 8. Please stay with me on these instead of trying to work ahead, because these are difficult. These are hard. All right. All right, we have number 1 here. Working alone, it takes Matt 14 minutes to sweep a porch. Are you with me so far?
Yes, ma'am.
I'm going to stumble on these names. Please forgive me. We got Pranav. Can sweep the same porch in 13 minutes. How long would it take if they worked together? Okay, so I'm going to make a rudimentary equation here. First we have Matt. Matt plus Pranav working together will equal all of it together. Are you with me?
So add it all together.
So we're going to this is our basic equation. That's an R sticking off there. It just can't fit. All right? So, you with me so far? So, since we have we have Matt working a certain amount of time, and Pranav working a certain amount of time, we need to break it down so we can put the same things in here. We're going to say, how much does Matt do in an hour, and how much does Pranav do in an hour? How much does Matt do, in 1 minute, in 1 minute?
1/14.
1/14. So we go 1/14, so we can put it all in one type of unit. 1/14 of the job he can do in 1 minute. What about Pranav? 1/13. Okay? And we want to know how much it's going to take them to do all together, but we still have to keep it in minutes. So we're going to have it go over here, and I'm going to call that x, because we still have to keep it in the fraction, because this will be in, if we solve for that x, this whole thing at the end will be how much how much of the job can be done in a minute, but when we find x, we'll know how much it took them to do it all together. Are you with me so far?
Yes, ma'am.
Okay. So what I need you to do is you can either do this out long, find the common denominator, and then add it together, or you can, last week we learned how to use your fraction button on your calculator. You can take 1/14 plus 1/13 and turn it into a fraction and tell me what that number is.
182.
182.
182 is 2.
All right. There's a couple ways to do this. I want you to watch the long way. Don't write anything down. Watch the long way, and then I'm going to show you a short way, and you can pick which one you're going to write down. Okay? So watch the long way. The long way, this is a proportion. We're going to cross multiply. We're going to go 27x, because I'm doing this right here.
Goes in like 6 times.
And then I'm going to do this right here equals 181 times 1, which is 182 times 1. What am I going to do now?
You're gonna divide
By 27. So it's 182 over 27. Someone do that on their calculator for me.
6 times.
6.74.
Look at that. I'm a genius. I can't believe I
6.74.
knew that.
That is what I got. 74 minutes. That is the answer. It'll take them 6.74 minutes to do it together. Now, I want you to notice something. This is the long way. I want you to notice when we have this thing right here, 1 over x. We had 27 over 182. What happened here? We inverted it. What's that another word for the invert when in math? What's the vocabulary word for that? Flip it upside down. Reciprocal. You have a reciprocal button on your calculator. I want to show you what it looks like. It's a button that has an X with a little -1 up there like this. And it is right below your squared button, or above your squared button. Above your squared button.
Okay.
Do you see it? Okay. So the fast way to do that is to get right here to this step and move over, put 27 over 182, because it's already in your calculator from your fraction you just did. It should be there. Mm-hmm. So all you have to do is just hit your reciprocal button and be done.
Yeah,
Working alone, Jimmy can pick 40 bushels of apples in 13 hours. Micaela can pick the same amount in 9 hours. If they work together, how much would it take them? So I want you to first give me that first basic equation that I had at the top. Something plus something equals together. Jimmy plus equals together. I'm going to do TO. All right, then we have, after that, we set it up so that we did some fractions. So what's the fraction for Jimmy? 1 over 13, I agree.
Brett,
This is in hours.
22 going to
What
13.
about, we're not going ahead. What are we doing for the fraction for Micaela? 1 over 9. Do we agree so far? What about the together?
1 over x.
Okay. So you now could, on your calculator, find 1/13 plus 1/9. Tell me what that fraction is.
22 over 117.
Oh, dang it.
All right. And now, you guys have that in your calculator. You can now use your reciprocal button. Some of you might have to turn it back into a decimal after you're done, but reciprocal and decimal.
Well, if I just hit enter, it goes into a decimal. If I don't, and I do the fraction, it's fine.
Mine just went into the same exact thing.
Oh, fantastic.
So I'm guessing you just never turned it into a fraction.
Oh, that would work. So if you don't turn it into a fraction, then do the reciprocal, then you'll be fine. Ah,
So
okay.
you turn
So
it upside down, then you turn it
so-
back right side up.
So now do the reciprocal.
the question was how many decimals? How many decimals does it say to give?
Here's 100.
Here it's 100. How many is that?
2.
2 decimal places. All right, so how many? What is that? 5 point? What do you
Wait.
guys get?
Ooh, where did
Mine
you?
just flipped
5.32.
I got
Mine just flipped
5.32.
the reciprocal.
Exactly. So 5.32 is what I got. Let me help you with your calculator because this is part of it. Working alone, Julia can pick 40 bushels of apples in 9 hours. One day, her friend Jill helped her, and it only took 4.74 hours. How long would it take Jill to do it alone? Now, this is a different one than we had before. We have our initial equation is still Julia. I'm going to do a JU because we have Julia and Jill. We still have it together, and if you want to put a T for together, that works for me too. But when we plug in, this is the different part, okay? Julia, we know how much Julia did. She worked 40 bushels in 9 hours. What do we put under Julia? 1/9. Jill. What do we put under Jill?
The 1 over x.
That's the one. We don't know this one. So this is the 1 over x. But we do know how much they did together.
1 over 4.74.
There's a garage.
Yes, 1 over
No, it's not power.
4.74. Now, how are we going to get that 1 over x by itself? We're going to do that by moving that 1 over 9 over by subtracting. When we do that, next, we're going to put this right here into our calculator. When we put that into our calculator, you'll get a decimal. Then you're going to take the reciprocal, what that tells you to do. When you put this portion into your calculator, you should get 71 over 711. Now, some of you, because of the way your calculator is configured, you should leave that as a decimal. And others of you, you were able to give it as the fraction. And when you put this in your calculator as a reciprocal, you take the reciprocal button, you will get 10.01 hours. R stands for rate. I'm gonna you can put this in your notes if you'd like. Rate, that's like how fast. That could be in miles per hour. That could be kilometers per hour. Usually it's going to be in hours, but it could be meters per second. It's rate, okay? T stands for
I have no problem with
time. We're on our notes now. We're on our notes now. Back at the right there. Okay. And T, it should be D stands for what?
Distance.
Distance.
equals rate times time
Yes, distance equals rate times time.
times time
Mm-hmm.
times.
Times time. Rate, time. Rate times time. You with me so far?
Mm-hmm.
Okay. We will be drawing arrows, and if you want to put ships when they're ships, or people walking when they're walking, that's up to you. But we will be drawing pictures to set these up, and we'll be using equations. We will be using this distance equals rate times time to do this. Has anybody seen problems like this before?
Yes.
Something like it, a little bit? Okay. All right. That helps me to know who's where on this. Okay, so you don't have to have prior knowledge to do this. All right. We're going to do numbers 13, 14.
On the same sheet we were doing.
Yeah, the same one. Mm-hmm.
So
13, 14.
Mhm.
I don't think there's going to be as many tricks, Isaac, so you don't have to worry about all the tricks for the calculator stuff, okay? 13, 14, 17, 18, 21, 22.
Well, you gave us a lot more
25 and a
this week
6.
than we did last week.
I like it. Let's actually do that.
Now, there's something you need to notice on these, but I'll bring it up in a minute. There is not any of the let's review or let's, what is it called? Looking back. There's the looking back section on the very first one. There's none of that on this first one because there are so many of these word problems. Okay?
Britt starts crying.
Okay, remember I'm giving you a little note that says stay with me because
Don't
these are
cry.
difficult.
Then don't cry.
All right? So these are difficult, so stay with me.
Yes,
Are we
do.
ready?
1, 2.
We sweat through our eye.
No,
See
real
how
men
this-
cry.
No, it's
We're going to resume. Mike, we ready? You got Mike? We see this up here? Mike. Mike made a trip to the ferry office and back. All right, so we got, I stopped there. I'm not going to read anymore. I start drawing. He went forwards, and then he went backwards. Something you need to take note of now is that the distance is the same. If you walk to a place and then you walk back from there to the same place you started, the distance is the same to and from. That is significant. Unless you use a different route, and they didn't say he made a different route, so you're going to assume that he worked the same route. But you're right. You could, go to Walmart on the way home, but he didn't. Okay. All right. So on the trip there, I'm going to call the top one there. We're going to do 60 miles an hour. I'm going to write 60 miles per hour. This is the way I fill out it's kind of like a little bit of a chart a little bit, but he went 60 miles an hour. And on the return trip, he did 75 miles an hour. So where do you think I'm going to write that one? Right underneath. Go ahead and write this down. I think it's going to be helpful for you. How long did the trip take if the return trip is 4 hours? So I'm going to put over here 4 hours. And we don't know T up here. I'm going to put a T equals question mark. That's what we're looking for. You could call it X if you want, but I don't want to. I usually use the letters of T and R in there. The most important thing is that the distance to the office is the same as the distance from the office. It's very, very important that you realize that, because sometimes there's going to be different things that you're going to compare. But this type of problem, the distance to the office and back from the office is the same. That's why I put the little subscripts to and from. Are you with me so far?
Yeah.
That means, because distance equals rate times time, in the place of that distance, I could write a rate, 2, and time, 2. I just substituted rate and time in there. Are you with me so far? What am I going to do on the second side, on that distance? What am I going to substitute in for that distance and time?
Rate from and time from.
Yes, I'm going to do a rate from and a time from. Ask me some questions if you don't know what I'm doing.
I'm just going slow.
No problem.
I'll be writing. the
I
whole
got
time.
distance
I'm
equals
confused
rate times time, and in that place of distance right here, I'm plugging in rate and time. We know 3 of those 4 letters in that equation. Do we know the rate to the office?
Yeah.
60. I'm not going to write the units at this point. 60. Do we know the time to the office?
No.
No, we're going to call it T. You don't have to put the dot there if you don't want to. Do we know the rate from the office?
Yes.
75, correct? Do we know the time from the office? 4. Now, it's just algebra. Just algebra.
Just.
I'm going to let you figure it out. I'm going to work it, and you're going to work it, and we're going to come together at the end and see if we get the same thing. Make sure you don't forget your units at the end.
5.
Mm-hmm.
That's what 2 people got. Let's check it to make sure other people get 5.
5.
Okay.
5 hours.
Hours. That's what I got. 5
Yeah.
hours.
I know you about to be like 5 what?
5 what?
Yawn. I'm too brain dead. Sorry.
All right, we're going to skip number 14 and move on to number 17. Kim traveled to the lake and back. We're going to draw that first. We're going to draw to the lake and back. To the lake and back. Notice that our distance is the same. We're assuming that they didn't take any, different route on the way back than they did to. Let's keep reading. The trip there took 3 hours, and the trip back took 2 hours. So let's put our times in. Now let's look at the rates. Here we go. She averaged 15 miles an hour faster on the return trip than the outbound trip. This is significant. So she was faster on the return trip than the outbound trip. So we're going to also keep reading because we need to know which one needs to be R. So we're going to finish the sentence. What was Kim's average speed on the outbound trip? The outbound trip is this one right here. This trip is the outbound trip. This is the return trip. And so on the outbound trip, she was faster. So we're looking for R, right? We're looking for the outbound trip here. And it says she was, actually I said that wrong. She was faster on the return trip. So she's 15 miles an hour faster. So we're going to keep this outbound as R because we're looking for that at the end and we want that one to be our answer. And we know that she was 15 miles an hour faster on the return trip. So we're going to make that one R plus 15. So now our distances are equal. To and from. We're going to substitute in our rate and our time. This time we are not going to write the R and the T and the R and the T on this side. We're just going to substitute the rate times time. We have this rate and time we can multiply together, and this rate and time we can multiply together. Let's try it. We have 3t on this side. That was these two. And now, how are we going to write that second one? Can we write it like this? Be careful. We cannot. We must put some parentheses around those. Let's distribute the 2 to the r and the 15. Then we can bring that 2r to the other side by subtracting, and we'll have r equals 30. And we're looking this time for speed, so we have 30 miles per hour. All right, I love this one. I didn't pick the place. It automatically picked it. And I did live on Guam. A cruise ship made a trip to Guam and back. The part you need to realize right now is the distance is the same to and from, okay? All right, so to Guam and back, so we can stop right there and just draw our 2 and back. All right, so the trip there took 2 hours and the trip back took 5 hours. So I always put my T's first because I do like to do R and T. So T and T, 2 and 5, and you can write the hours if you like. Sometimes it's nice to help you remember the units. What was the cruise ship's average speed on the trip there if it averaged 10 miles an hour on the return? So R here is 10. We're looking for that R. We know our distance to is the same as our distance from. I'm going to let you guys set this up yourself and work on it.
Yeah, it's a negative. I got a negative number.
You can't have a negative miles per hour.
That's correct. You can't. So let's do it together then.
That's not 5.
So what over here? What did you put for your equation on the 2 then?
I got a negative 2.
What'd you put there?
I got 2r equals 5, open parentheses.
2r. I agree with 2r
Not R
equals.
plus 10. It's just R. It's not faster. It's not 10 miles per hour faster. It's just 10 miles per hour, period.
That's
So
correct.
you can substitute 10 in for R.
Okay, so you just
So
get...
it's just
That's correct.
50.
Yeah, so did you notice that it said it was it just averaged 10 miles an hour. It didn't have 10 miles an hour faster, just 10 miles an hour.
So 25?
25,
So-
yeah.
That's what
Yes.
So this next one over here is going to be 10 times 5, or 50. I'm going to divide both sides by 2. And R equals 50. That's going to become 50. Divided by 2 is 25. 25 what? Miles per hour.
I'm critical.
Here we go. Almost 2. Are we ready?
Oh.
Jenny left home and drove towards the train station at an average speed of 70 kilometers per hour.
1 kilometer.
It doesn't really matter the units. You're just going to write them down. Anali left 1 hour later and drove in the opposite direction at an average speed of 35 kilometers per hour. Now the distances are not equal. I, personally, since I like to draw, I'm going to say this is Jenny. And this one is Anali.
Jenny.
All right? I don't know if the distances are equal now. How long does Anali need to drive before they are 385 kilometers apart? So this is what I do. I draw little lines here, and I want the total distance to be 385 miles an hour. Are you with me so far? Kilometers per hour. Kilometers in distance apart. So that means that the distance of Anali plus the distance of Jenny is going to be 385 miles an hour. I kept saying that. 385 kilometers, period. Are you with me so far? Mm-hmm. So we're going to substitute the rate and time of Anali and the rate and time of Jenny into those distances. Do we know the rates?
I'm going to swap Anali and Jenny since Jenny's mentioned first because I'll end up
Right.
putting the things.
And we want to know how long Anali, so we want to know the time for Anali. So we need to make that one T. Anali left 1 hour later, so did she travel the same amount of time?
No. So we subtract 1 from her?
How much? 1 hour. So that means that, but Anali was 1 hour less, but we need to do a time for Jenny.
Or just plus 1?
Plus 1 for Jenny. Yes. Are you with me?
We don't do subtraction.
So
just
T
plus
plus 1, because we want the T that we're looking for to be Anali, because we're asked to find Anali. And Anali was 1 hour less, so that means Jenny's 1 hour more. Are you with me?
Yes, ma'am.
Okay. So what is Anali's speed? 35 kilometers per hour. And Jenny's speed is 70, I believe.
Mm-hmm.
It's about 4 hours.
He's estimating because he doesn't have a calculator. 4 hours. So what are we going to substitute in for this Anali's distance?
So 7. Oh, sorry, not. Yeah, 7. No, sorry. 35x.
Or okay, x. I'm going to do t, but you can do x. 35t. What are we substituting in for Jenny's distance?
70 open parentheses t plus 1.
I'm gonna have to make it a capital T.
You can make it. You and on your that's actually something good to note. I said.
Why is it a T plus 1?
Good question.
Yeah, got a good question.
All right. Up here I'm going to highlight it in yellow. It says that Anali left that's not a bad highlight. Anali left 1 hour later. So I also am going to underline this. How long does Anali need to drive? So I am going to put T for Anali because we're looking for Anali's time. So I put a T right there. Are you with me so far? And up there it says Anali left 1 hour later. That means she was 1 hour less than
That's how I do.
Jenny.
Oh, is that why you put the -1?
Well, I put a +1 because because Anali is less than. That means Jenny's 1 more than.
Okay, that makes sense.
Does that make sense? Okay.
So, could it work both ways if I just put 35t -1?
Yes, if you come over here, if you made this one T, and this one over here T -1, but when you're done, you will not have Anali's time. You will have Jenny's time. You're going to have to calculate the correct one after you're done. If we do it Isaac's way, and I go T on this one and T -1 over there, you won't have the right person. You'll have Jenny's time, not Anali's time. And the question said Jenny's time. And that's not a problem as long as you realize that you need to then... I understand, but but Isaac's going to wanted to do it backwards. He didn't like the adding instead of the subtracting. All right, so I am going to come down here and pick purple. And I'm going to go 35.
I'll try not to forget my calculator next time. I just got about 4 hours.
I'm not
Would I get it? No. Would I get it right if I put about 4 hours?
No.
No?
No.
Just guesstimating.
Okay, that 35 plus 70 is going to be 105t. And when I subtract the 70 over there, I'll have 315.
Mm-hmm.
315 divided by 105 is how much? I heard 3. Does anybody else get 3?
No, right. Yeah.
3 seconds.
3 seconds, minutes, hours, days.
Hours, right?
Are we finding time?
Time. Says
Hour.
how long.
How long is this? Minutes, hours, days?
Kilometers per hour.
right?
Are we finding hours? Are we finding
We're
speed?
finding hours. We're
We're
not finding speed. We're
3
finding
hours.
time.
It takes her 3 hours to get to the same distance apart. That's what it wants us
Yeah.
to find.
So-
it takes her 3 hours total.
Yes, so hours. Okay. All right, let's review what we've done. We learned how to determine the time to do a job or some work. The trick to this one was making sure that we put fractions 1 over the amount of time to determine how much was done in 1 minute or 1 hour or 1 unit of time. And then we used different distance equals rate times problems, and there are more to come later. Enjoy!